In this video, we're going to find out what syntax is, and more specifically, what C# syntax is. So, what is syntax in general, right? Well, simply put, it's the rules of a language. So, if we bring up a text editor, and I'm just going to write a sentence down here, the boy is good. We can see a lot of things at work with the syntax here. Boy is our, object. It's also a noun. Is like the verb in the sentence. Uh, so we have a lot of different rules and stuff we've learned in English going on until we all kind of came to this agreement that, yeah, these random scribbles and letters, I know what that means and I can read and I'm literate now. So syntax allows communication and languages to exist. There's even syntax in something like this. I guess I don't need a space. Or, this. Oh, wait, no, that's not good. Yeah, I like that one. That's like the big happy face. So simple emoticons and emoji is also a layer of syntax or a different form of syntax. Same thing with hieroglyphics. Same thing with Spanish. Anything that allows us to communicate, and then the syntax are the rules that we all agree upon to understand these things. So they can be text-based, as we see here with our actual letters. They can be special character-based, as we see with emoticons. And inside of Unity, we use both text-based symbols and special character symbols as well. So it can either be text-based or visual-based inside of our game engines. Whenever we talk about syntax, we also have more, abstract ideas to think about, such as whitespace. So if we bring back my editor, then everything there's not something is what we call whitespace. This whole line right here, whitespace. This whole line right here, whitespace, whitespace, whitespace. And inside of programming or an editor like this, whitespace is purely used for organizational purposes. It doesn't slow down the code anymore. It doesn't mess up the syntax. Whitespace is our friend and helping us organize our thoughts, organize the layout of our code, and we can use it basically as an organization tool. Keywords, let's look at what keywords are. So you'll notice there are different colors of font inside this game engine or inside the script right now. So we can see that functions are written in blue, like this void start function. Comments are written in green. So this double forward slash will say that, hey, ignore this line of code. This is for informational purposes only. Our class name is in cyan. So this automatically happens too whenever we type our code. So if I was going to declare and assign a variable, I could say int, my int equals 4. And you'll see that my the int word right here automatically turned blue, and the value I assigned it turned kind of like a light green. I don't know if you can see it. Let me zoom in. So we kind of have a light green there. So really useful tool that helps us formulate our syntax a little bit easier. And the colored text in the IDE, which stands for Integrated Development Environment. And what we're going to be using in this class is Microsoft Visual Studio. There's going to be a whole lecture on that in Chapter 2. So we'll get there. But being able to turn the color of certain words helps us organize our thoughts as well. And of course, we have tons of symbols that we use inside of programming. Yes, believe it or not, every one of these symbols has a very important function. And you can even see them at work here. We can see our parentheses at work, our curly brackets doing stuff, this random semicolon somewhere for some reason. Oh, there's just a regular colon, I guess. These double forward slashes. So all of these random symbols and characters have very specific uses that, hey, guess what? It's just part of learning the syntax of C#. Let's also talk about the order of operations. Uh, a lot of programming is very logic based, very mathematical, very orderly, right? So whenever you were learning about "Please excuse my dear Aunt Sally" back in the day, yeah, it's rearing its head up again here, and it's very, very necessary and very important inside the world of programming. And I'm going to write a simple equation that may look somewhat familiar if you've ever played a video game. So I'm going to I'm going to declare a variable. I'm going to say int player health, and this variable right here is going to hold my hit points for my character. All right. So in my update, we're going to say if you know I get see it's not going to like I get hit. This is not going to compile. It's very wrong syntax, but it's going to get the point across. If I get hit, so this is like an if statement that we'll get to. So if I get hit, then we need to do something to my player health, right? So what we're going to say is we're going to say player health now equals my current, oh, spelled that wrong, current health, all right? So this is how much health I currently have in this frame. And then we're going to subtract a damage amount from it. So we're going to say, and notice how I already have parentheses working, right? We're going to minus damage, okay? So this right here, and then we're terminated with a semicolon. This basically says my health will be my current health minus enemy damage. But what happens if enemies have a damage boost and they get their damage squared? Well, we're going to come in here with our order operations, and we're going to square that damage. So this little caret symbol right here represents exponents. So when we do order of operations, we're going to look for exponents. Please excuse, right? So parentheses first, then exponents. So we're going to square the enemy damage, and then we're going to subtract it for my current health. But I have some super armor on, and all my damage is halved. I only take 50% damage from enemies. Well, we use the power of our order operations to, as soon as we square our damage, you know what? Why don't we do a new order of parentheses here? So I'm going to do another parentheses. Yep, nesting parentheses within one another. And then division 2, and then close that parentheses. And you'll see Visual Studio is doing something very important for us to help us keep track of our order of operations. See how when I have my cursor next to this parentheses right here, see how it highlights its partner? All right, so by order of operations, this is what we're going to say now. First, I get hit by an enemy bullet. Then we're going to take my current health, but before we can subtract a number from it, my damage, or the damage of enemies, has been squared. They have a buff going on right now, but I also have super armor on. So we're going to do that little bit of parentheses here, and then we get a number. And then these parentheses right here say, hey, after you square that damage, divide it by half for that super armor. And then this whole statement gets solved, and then we can subtract whatever damage number this is from our health, and boom, that is a algorithm in a very simple form, but an algorithm that figures enemy damage boost and armor mitigation for damage. And that's basically how we can do some very basic stat related math inside of games, stuff that you kind of take for granted. This is how we kind of spell it out for ourselves. So order of operations, very important. I urge you to kind of look back here and remember, basically review on how it goes. Anything in parentheses is done first. And then anything that has an exponent, like the little caret symbol right here, and then or the square. That's how we do roots. So boom, boom, exponents. And then we look for anything that's multiplied or divided. And if it's if there's two symbols in this level, then we read left to right. So we divide and then we multiply. And then under that, we have addition and subtraction. Same thing, it reads left to right. We don't add 5 and 10 together first. No, we read it left to right. So we subtract 5 from 4, and then we add 10 to this value. Order of operations, I spent a little extra time here because it's just that important. All right, so I've already made use of several special characters and uh, other future concepts like variables and conditional statements. But let's find out what these special characters actually mean. We've talked about these special characters. So let's start with a semicolon. You can already see that I've used a semicolon right here, right here. Basically, anytime you make a statement like saying, hey, I want to create this variable, well, end it with a semicolon. Or I want to do this equation, end it with a semicolon. And yeah, we don't do semicolons on things like function calls or if statements or anything like that. Basically, line statements like this are where we get our semicolons. And it may seem a little weird, like what's the difference between this kind of statement and a conditional statement? Well, it's the rule. It is literally the syntax rule, right? So anytime we want to actually do like an action, we're not asking a question, we're not calling on some kind of pre-rolled function. We are actually doing a thing. That's when we will end the line with a semicolon. A lot of rule of thumb stuff, and a lot of stuff you'll just pick up naturally, like, as if you were looking at a comma in an English sentence. Let's keep on going down. Parentheses. We've already seen them help with our order of operations right here with our weird damage calculator. But we can also see we have parentheses right here with these function calls. And inside these parentheses, sometimes we might have to have special variables that get passed into our function so they work. So we can basically, these parentheses work for functions by holding special variables that we work with, and that'll become more apparent as we get into functions later on in the course. But parentheses not only help with our order of operations, but they can hold variables or parameters for our functions. Curly brackets, we can see that in action right here. So we have this void start function right here, and this says, okay, we're going to do a bunch of things at the very start of the game, the very first frame. What kind of things are we going to do? Well, a few things. Well, what things? Well, anything inside of these two curly brackets. So we can say, okay, do this stuff, right? And since white space doesn't matter, we can organize our curly brackets in our code any way we want. So this right here, anything between these curly brackets gets done in our void start function at the very beginning of our game. It really helps to find our scope. Scope meaning only this part of my code right here I want to be able to do at the very start of the game, while this code gets done every single frame. So that's what we mean by scope. It's almost like a little world inside of a bigger world. Again, the concept of hierarchy, inheritance, rears its head again, right? It's going to be a common theme we see. Don't forget the straight brackets. So whenever we have a list of data that we may want to keep hold of, like, I don't know, 2, 3, 6, 8, and these all relate to, I'm trying to think of a good example. You know, bullet, or how about these numbers represent equals machine gun. Better comment that out. Machine gun ammo. So we have 2 bullets for our machine gun, rockets, popper, fireworks at the dollar store. That's a pretty good weapon. And then nukes. That's pretty standard any kind of sci-fi soldier's uh, rucksack of destruction. So we kind of have a list of different numbers, right? Well, we have variables in the future we call arrays, and basically an array is like a variable that holds all those variables. Pretty crazy, right? So we can say something like int my ammo array. And then if I wanted to point to my rockets and get at that value right there, then I'd use my brackets and I'd say 1. And now I can say, oh, I don't want 3 rockets. I want this many rockets. Okay? Well, okay. What's going on here? Well, my bracket says this isn't just a normal integer. It's an integer full of it's an array full of a bunch of different integers. And this number right here in my bracket points at the value in my list. Well, rockets is number 2, not number 1. Well, the great thing about computers is we start counting from 0 most of the time. So my machine gun ammo equals 0 in the array. Rockets equal the 1 position in my array. So there's a quick little intro to arrays and how straight brackets help us point at individual values within my list of whole number integers. It's not that confusing, right? Just a bunch of words and numbers being thrown at you really fast. But we got to be exposed to it, and the more we look at it and the more we delve into the stuff, the more comfortable you'll get. Double quotations, it's how we define a string. You can see how I use double quotes right here to, what we got right here is a string of characters, and notice how it's orange now. By the way, this is completely terrible syntax for the if statement, but I wanted to bypass some of the more icky stuff of conditional statements and basically said we're just checking if I get hit. So if we were going to do that the right way, I'm going to come down here and I'll declare a string variable called my string, and then we can say something like my string. Oh, notice how it worked for us there. I said my lowercase string, and if I hit tab, it'll even auto-complete it because look, we already declared my variable up here, and now Visual Studio knows, hey, my string is a thing. It's at play. And then we can say my string equals hello world. And then what do we do when we're doing a thing? We always end it with a semicolon. So you'll notice if we want to type out text and make that an actual variable, our double quotes let us do that. We've already seen me use comments, and you'll notice anytime I use a double forward slash right here, then I make a green comment. And basically, anything that's got a forward slash, double forward slash in front of it is ignored by the game, ignored by Visual Studio, ignored when the code is compiled. It's basically just there to remind us, hey, what the heck is going on? So we can see that we have a comment saying, update is called once per frame. Oh, thanks. That's what void update does. Or void start. We use this for initialization, or initialization is just a fancy way of saying, hey, everything's starting up. Let's declare stuff. Let's get things going. We're initializing all of our variables. We're getting it ready to go. There's another way, a more sophisticated way to do a larger bodied comment. So if I come down here, I'm going to go down here below my curly brackets. And if I want to write a bunch of different things for a comment, like a paragraph explaining what's going on, I can do a forward slash asterisk. And then I know it made those asterisks for us, but we don't need all those other ones. And then an asterisk forward slash. Anything in between here, oh, I can't type. is a comment. But as soon as I go outside here, now it's white. See how that works? I don't know why I put a semicolon there. But that's how we can use comments. Comments are really great for a few reasons that we'll look at in a second. Oh, or actually right now. You can do a file header with using comments in your code. So you can come up here and give me a few lines of code up here, and then I can go Patrick Roeder. You can put the date, 1/8. I'm not going to tell you what year it is. Okay, you can see it on the computer screen. That, and then you can do something like, oh, that's pretty cool. This code is a test. It's a pretty simple test. So you can kind of give yourself a header for your file, or you can do what the Unity guys can already have set up for you and give you reminders on what a function is about to do. Like this function is called once per frame, or you can even come outside of like a variable and do something like this and say this stores the player's health, and that kind of, this is a random variable for demo purposes. And this is really nice, and I really want everybody watching this to get in the habit of almost over commenting on your code, because when you come back to your code to kind of remember what you were doing there, maybe you hadn't touched it in a week or two, then the more comments you have, the easier it is going to be to kickstart your memory. Or if somebody brand new to the project walks on and all they have is just straight code, then they're going to have a harder time tracing through the code, figuring out what does what. But if they kind of get an idea of what you're thinking when you were making this stuff, that's going to make the code a lot more team friendly, right? Let's look at a few errors real quick and then call it a day. So a syntax error is breaking the rules of the language. It makes the code not compile, and then I don't know if you can attach it. I think you can still. Let's just test it out. Let's make some syntax errors here. I'm going to go ahead and delete this if statement because that's a nightmare. In fact, I want to kind of keep that equation for future posterity. It's angry at us. We already got some syntax errors here because we don't have a variable called current health defined. We don't have a variable called damage defined. So why don't we just make those? Current. Well, since it's already broken, let's see if we can attach it to a variable. And you'll know it's broken because look at these little red squigglies. Something that works has never had a red squiggly mark written underneath it in history, except on Backwards World. So we got this test script. I'm going to go ahead and attach it to my directional light. So that little bit of information might be a little bit outdated. Even if there is a syntax error, you can still drag and drop your scripts onto objects. And look at that. We have test script now as a component for my light. Isn't that crazy? If we want to get rid of it, we can click our gear cog and go to remove component there. So that information is a little outdated. Apologize for that. But what syntax errors do is, let's go back to my Unity project and press play. All compiler errors have to be fixed before you can enter play mode. So syntax errors will prohibit you from running your game. So let's fix that. Let's create these variables. Current health and damage. And now Unity is happy. Because at first it was like, you want me to look at current health. I don't know what that is. Is it an integer? Is it a function? Is it an array? Well, now it knows. It's just a regular old integer when we declare it up here. Same thing with damage. It didn't know what damage was. But now it's happy. And if we go back to Unity, then we can see this little text field down here. It's not red anymore. We go to the console window next to our project window. you're going to be living a lot in the console window, let me tell you. We can see that there are only a few warnings here, but no red syntax error messages. And we can hit play. Granted, nothing's really happening here, but at least it compiles. A segmentation fault won't show us an example here, but we'll see it whenever we get more. A great example is creating an infinite loop, but it's basically a memory access error. So if you're in an infinite loop doing an addition statement over and over again, you're just constantly adding infinitely every frame, then you're probably going to run out of memory, and yeah, your application is definitely going to crash. So a segmentation fault is project crashing. It's not game breaking, it's game project breaking. So we want to make sure we don't run into these. And the most devious part about segmentation faults is sometimes the compiler or the console window won't catch the error. So it'll let you press play, and then it'll just crash Unity. And that's an infinite loop for you. And then a logic error is something like this. So every time we get hit by an enemy bullet, a logic error would be if we accidentally added that damage to our health. So every time we get hit by a bullet, enemy bullet, we get healthier. The game's not going to catch that. Compiler error's not going to catch that. Unity's not going to crash. You're just not going to have a good time in your game because, you know, you got broken logic going on. You could never die. There's no challenge. That's a logic error. All right, guys. That about does it for the basis of syntax. Hope you guys learned a lot with all these different special symbols, and order of operations can be a little bit tricky. But you know, if you just keep in mind the rules and, you know, give yourself plenty of white. Even I use Whitespace right here to kind of keep track of, you know, that's a thing, and then this is a thing. And even Unity helps you keep track of your parentheses. Remember, by highlighting its sibling parentheses right there. So that's good stuff. And really just all the different rules, base rules of syntax, such as Whitespace, keywords that turn different colors that we've seen in action. And yeah, we use symbols and text-based stuff. As you can see here, symbols with these curly brackets and parentheses, text with actually giving ourselves commands. All right, so that does it for this video. Thank you.